In this video, what we want to do is solve what we call simultaneous equations. So simultaneous equations are two equations that occur at the same time, and they're in two variables. So if we've got an equation just in two variables, and it's by itself, then there's an infinite number of values for x and y that could satisfy this equation. So 2x plus y, we could put an infinite number of numbers in for x and y, and that could be equal to 6. But when we get a situation where we've got two equations together, there's only one value for x and one value for y that will satisfy both those equations at exactly the same time. And that's why we call them simultaneous equations. Now, there's a number of ways we can do this type of equation. And this one's called a substitution method. Now, notice these two are both what we call linear equations. We can do it with other types of equations, substitution with other types of equations. But we start off with linear because they're the most simplest equations. Now, our convention is to label the equations. So I've got equation 1 up here, and I've got equation 2 there. Now, our aim is to try and get an equation from these two that would be in one variable. And we're going to try and do that by getting a substitution from one equation into another. So what I'm going to do, I'm going to take equation 1 here. So from equation 1, what I'm going to do is just rearrange this equation and say that, well, that could be written as y is equal to 6 minus 2x. Okay, so all we've done is subtracted the 2x off both sides. And so I've been able to write it in that fashion. Same equation, haven't changed it at all. But then what we're going to do is we're going to now substitute the y into equation 2, and that will give us something in just x. So we're going to substitute now into 2. So we'll write that down so we know what we're doing, and letting anybody else who reads our work know what we're doing. So that would give us 5 lots of x, and we'll subtract now, instead of subtracting y in this equation, we're going to subtract 6 minus 2x. So what we're actually doing is we've got rid of one variable and now got an equation just in one variable, which we can solve for that variable. We couldn't solve an equation by itself when it had two variables, but we've eliminated one of the variables here by substituting one for the other. So what we do then is just clean it up. So 5x minus 6 and minus 2x would give us positive 2x. That is equal to 1. Collect our terms, we get 7x minus 6 equals 1. And we get 7x equal to 7, and x would be equal to 1. So there's our value of x that makes this statement true. So if x is equal to 1 now, what I'm going to do is substitute it back into this equation and find the y value. So y must be equal to 6 minus 2 lots of 1. So 6 minus 1 gives us 4. So y is actually equal to 4. So there's what we call a substitution method. We take one equation and we substitute it into another. And this one wasn't too hard because it's a pretty simple manipulation. They do get a little bit harder. That's why we call this one a simple question. We'll start off simple and then we can work up to harder ones. But we were able to get one equation in terms of the other and then do the substitution into the other equations.